Hi everyone, this is NLP Corgi. Today's deep dive is about the paper from Fudan University, OmniLottie, generating vector animations via parameterized Lottie tokens. Vector animations power modern interfaces, icons, and motion graphics across apps and websites. This paper introduces OmniLottie, a model that can generate fully editable vector animations directly from text, images, or even videos. Instead of producing raster videos, it outputs Lottie files, lightweight animation formats widely used in design pipelines. Generating vector animations is fundamentally different from generating images or videos. Formats like Lottie store graphics, layers, and motion parameters inside deeply nested JSON files. If a model tries to generate this raw structure directly, most of its effort goes into reproducing formatting instead of learning meaningful animation patterns. As a result, many existing models produce invalid outputs or fail entirely. The core idea behind OmniLottie is to rethink how animations are represented for a model. Instead of raw JSON, the system converts animations into sequences of commands and parameters. Each command represents something meaningful, like creating a layer, moving an object, or rotating a shape. Continuous parameters like position or scale are discretized into tokens. This turns animation generation into a structured language modeling problem. OmniLottie builds on top of the Qwen 2.5 VL multimodal model. The system introduces a new tokenizer specifically designed for Lottie animation commands. When given instructions, such as text prompts, reference images, or videos, the model processes them alongside the animation tokens. It then generates the animation step by step as a sequence of structured commands that can be converted back into a valid Lottie file. Training a model like this requires large amounts of vector animation data. The authors created OmniLottie 2M, a dataset containing 2 million animations. They collected professionally designed Lottie files from multiple platforms, cleaned them, and normalized their formats. To further expand motion diversity, they converted static SVG graphics into animated Lottie files, using motion templates extracted from real animations. One strength of OmniLottie is versatility. The same model handles several generation tasks. It can create animations purely from text descriptions. It can animate objects based on both text and reference images, and it can even convert a video clip into a vector animation that preserves motion while remaining fully editable. All of these tasks use the same underlying autoregressive generation framework. To evaluate models fairly, the authors introduced OmniLottie Bench. It includes both real animations from professional designers and synthetic evaluation data generated with modern AI systems. The benchmark measures visual realism, alignment with prompts, motion correctness, and reconstruction quality when converting from videos. Across nearly every metric, OmniLottie outperforms strong baselines including GPT-based systems, Gemini, and commercial animation tools. It achieves significantly higher success rates in generating valid animations and produces motions that better match user instructions. In video-to-vector conversion, it also preserves temporal dynamics more accurately than competing approaches. A key finding is how critical the tokenizer design is. Training directly on raw JSON leads to extremely poor results, because the model spends most of its capacity on formatting. The command-based tokenizer dramatically shortens sequences and highlights meaningful animation components. This allows the model to focus on geometry, motion, and temporal structure. Despite strong results, the system still has limitations. Autoregressive generation can occasionally produce invalid command sequences which break rendering. Very complex scenes or long animations also remain difficult due to context limits. Future research could improve reliability using constrained decoding, reinforcement learning with renderability rewards, or tighter integration with professional tools like After Effects. OmniLottie shows how large multimodal models can move beyond images and videos into fully structured design formats. By converting complex animation files into compact command tokens, the system enables reliable generation of editable vector animations. Combined with a large dataset and multimodal training, this approach opens the door to AI tools that assist designers in creating motion graphics directly from natural instructions.